Today we're going to look at interval notation. All right, so to describe the set of all integers between -2 and 4, okay, we can represent the list or the set as a list or a graph of the numbers on a number line, okay? So if I list out all of the numbers or integers, positive or negative whole numbers, that are in between -2 and 4, when I say between, that does not mean I'm including. So that means I have -1, 0, 1, 2, and 3. That is my list of numbers. If I were to plot these numbers on a number line, I would have -1, 0, 1, 2, and 3. And if I plot them on a number line, I would have a point here, 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 and here. Okay? We can also write the set using interval notation. So if we were to write it using interval notation, that means that it will look like what we have below. Okay, so below we would have, and it says we're talking about the set of all integers. So instead of it being an R right here, sorry, I'm gonna switch that, and it should be the Z for integers. Okay, so let me make that a little smaller. Let me change the thickness just a little bit. All right, so from there, it's saying that X is going to be the set of all integers. Remember that little E means element or member. So X is going to be any integer or the set of all integers. And let me use my highlighter here so I can point out the key parts. So this can be read as the set of all integers X this vertical line here means such that and then this last part here is stating that X needs to be in between -2 and 4, and they are not included on the boundaries. So it can't be equal to, and we know it can't be equal to -2 or 4 because you don't see the equal sign under the inequality. So let's look at some examples of our interval notation. So the first example says, suppose B is represented, and it says that X is the set of all integers such that X is in between 4 and 11 can be included. Okay, so when I write it down, I am going to say X is the set of all integers such that X is between 4 and 11. And we can say where 11 is all right. So if I want to list out the elements of set B, I would have 5, 6, 7, 8, 9, 10, and 11. All right. And if I want to, I can put it as B is equal to, and then I can put my brackets around them to write them in set notation. So part C says find the number of elements that are in B. So if I count up the number of elements in B, I have 1, 2, 3, 4, 5, 6, 7. I have 7 elements that are in B. Number 2, it says suppose that U, which is your universal set, and your U, and remember your universal set is the set of all of the numbers that you are considering. So I'm going to say all numbers being considered. That's what the U means. So suppose that all of the numbers that are being considered, which is my U, that's going to be all the integers from -6 to +6 included, okay? So I'm going to write out that my U is going to be from -6, -5, -4, and then I'm going to put some ellipses here to let you know it continues all the way 4, 5, 6. So all of the other numbers in between following the pattern. A is going to be the set of natural numbers from 2 to 5, and 2 is included. So remember, natural means positive whole numbers. So that means I can be 2, 3, and 4. And then finally, B is the set of all integers. And excuse me, let me change. This shouldn't be an N, it should be A, excuse me. Then we know B is the set of integers between -4 and 1, not including those values. So we're going to have -3, -2, -1, and 0. So for part A, it says, find the intersection of A and B. The intersection of A and B is an empty set because they have nothing in common. B, we want to find the intersection of not being in A, but also being in B, okay? So basically you want to figure out what values are not in A that are also the same elements that appear in B. So if we look at the set of B here, the numbers in B are -3, -2, -1, and 0. So if we look at the numbers that are not in A, that means that we have to ignore the 2, 3, and the 4, and we can basically choose -6. Okay, so I'm looking at not A, so maybe I'm gonna write that down. So my numbers that are not in A will end up being -6, -5, -4, all the way to all the way to 1, and then we can say including 5 and 6. So when I say where does not A intersect not B, okay, we would say 0. 0 is a part of that. We would also say -1, -2, and -3. So basically we will have the set of B there. Then it says we need to find the union of not A and not B. Well, we know what not A is, so when I say not B, any number that is not in B, so that means that we have -6. You're looking at whatever is not in B inside of the universal set. -5, -4. We know that -3, -2, -1, and 0 are in B, so we can't use that. And then we're going to look at 1, 2, and then we're going to go up to 6. So that is what is not in B. So if I want to find the union between not A and not B, all I'm doing is I'm combining the sets together. So I can already see that not A includes -6 all the way to a +1, including the numbers 5 and 6. And then if I look at not B, that's going to be -6 to -4, and then we're going to include the numbers 1 through 6. So basically, the union is going to be all of my numbers inside of the universal set. So if I say -6, -5, -4, and it's going to continue all the way to 6, that is going to be D. The union of A and B will end up being, and I'm gonna write it in numerical order, so we can say it is -3, -2, -1, 0, 2, 3, and 4. All right, so let's look at our last example, number 3. So number 3 states, suppose U is the set of all positive integers. So anytime you see something where it says like Z plus, that means positive integers. If you see N minus, or excuse me, N plus, that's the set of all positive natural numbers. If you see Z minus, that's the set of all negative integers. If you see real numbers, that means positive real numbers. This means negative real numbers, so on and so forth. So if you see a plus or a minus, that is just telling you that you're focusing on the positive numbers in that set or the negative numbers in that set. So here I'm focusing on positive integers or positive whole numbers. So U is going to be from 0, 1, 2, 3, and it's going to continue. Okay? Set H. It says multiples of 4 that are less than 40. Multiples of 4 that are less than 40. So I know the first multiple of 4 is 4. The next one is 8. The next one is 12, 16, 20, 24, and 28. Those are my multiples of 4 that are less than 40. And actually we can add, let's see, 30, let me add 32. And I'm going to add 36. It says J is the factors of 36. So your factors of 36 are 1, 2, 3, 4, 6. We're going to have 36 divided by 4 is 9. And then we have 36 divided by 3 is 12. And then we have 18. And then we have 36. All right, so A, it says find the intersection of H and J. Find the intersection. So H and J, they both cross at, let's see, they cross at 4, or they have 4 in common. They also have, let's see, 12. They also have 36. So that is the intersection, 4, 12, and 36. The union of those two sets is all of those numbers put together. So we're going to have 1, 2, 3, 4, 6, 8, 9, 12, 16, 18, 20, 24, 28, 32, and 36. So that is the union of those two. So now C, it says show that. Anytime they tell you to show something, they want you to prove it. So they're saying show that the number of elements that are in the union of H and J, we want to show that it is going to give me the number of elements of H plus the number of elements of J minus the number of elements that are in the intersection. So let's do it. If we count it up, and all we're doing is substituting here. So if we count up the number of elements that are in the union, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 elements there. So it's going to be 15 equals. If we count the number of elements that are in H by itself, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 9. Plus the number of elements that are in J by itself. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know 9 plus 9 is 18. And then if we subtract the number of elements that are in the intersection of H and J, that will be 3. So I know that 15 is equal to 15. So that is the way that I can show that that works. If you have any questions, please let me know, and I will be more than happy to assist you. Have a great day.